Today we're going to talk about the Cauchy Criterion for series. So let's suppose we have a series, a sub n. Very briefly, the kind of cheap way out of this, and then I'll explain what it means specifically in terms of series. The right way to think about a series, where this goes from n equals 1 to infinity, is right. You want to think about this as a sequence of partial sums, which I'll denote S1, S2, S3, da 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 da. Great. Well, kind of the quick way out of this is we can say, well, the Cauchy criterion for series is you just apply the Cauchy criterion for sequences to the sequence of partial sums. Well, then that means that for all epsilon bigger than 0, there exists an n among natural numbers such that for all n and m bigger than or equal to n, we get this result. Sm minus Sn. Oh, and let's make m bigger than n. Bigger than or equal to n. Like so. Right? This will be less than epsilon. That's what the Cauchy criterion for sequences says. So that's all we're really using here. But we can get a little more sense to what this means by expanding this out. Sm is just a1 plus a2 plus da 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 plus am. Sn is a1 plus a2 plus da 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 plus an. And remember, m is less than n. So what happens next? We get a log cancellation. a1 minus a1 cancel out. a2 minus a2 cancel out. Then finally we get, over here we have a little a sub n. That cancels out with that a sub n. Everything over here is canceled. And what do I have left here? Over here I have a sub n plus 1 plus da 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 plus a sub m. So that gives me a sub n plus 1 plus a sub n plus 2 plus da 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 plus a sub m. And what do we know about this? Oh, this was all less than epsilon. So therefore, right, the series is going to converge if for every epsilon there exists a capital N such that kind of this last, anytime that you're beyond a certain point, when you add up anything, any number of these terms, you get something less than epsilon. So that's really what it means in terms of the sequence. To give you an idea of what it means, maybe in a different way of looking at it, I'm going to write out a bunch of these. a6 plus a7 plus a8 plus a9. Why not just do 10 too? Let's suppose that, I don't know, if we're given epsilon, we have n is equal to 5 maybe for a given epsilon. Well, what that means is that if you want to be less than this epsilon, you can actually pick any run. If you add those four up, you're going to be less than epsilon. If you add up these three, you're going to be less than epsilon. If you add up, I don't know, if you want to add up a whole bunch of stuff, add up all this, you're going to be less than epsilon. Anytime you have kind of a run of consecutive terms, you're going to be less than epsilon. And this should make sense, right? Because if a series is going to converge, very kind of incorrectly, but maybe kind of intuitively, right? At some point you have to be adding stuff that's essentially 0. So what this is saying is that after a certain point, essentially, no matter how much stuff you add, it's all going to be equal. It's all going to be almost equal to 0, meaning it's going to be less than epsilon. So that's more or less what it means for the series.